This video focuses on operations with functions, so you can actually perform operations like addition, subtraction, multiplication, and division on functions just like how we would with numbers or expressions. The way that we perform these operations have a specific type of notation. We're going to start with the notation for adding and subtracting fractions. Part A shows that we have function f plus function g in terms of x. That's how I would read that. Function f plus function g in terms of x. So the function that appears first is the one that I'm going to write. So f of x is right here. So I'm going to write 2x squared plus 4x minus 6. And I'm going to add my g of x function. So 2x minus 2. I'm just going to put parentheses around those two to show you which function is which. So once again, we did f of x plus g of x. Because this is addition, we don't have to worry about changing any of the signs. All we have to do at this point is combine like terms. So I can get rid of these parentheses. Again, because it's addition, I just keep all the signs, so plus 2x minus 2, and combine like terms. So I only have a 2x squared, that stays the same. I have a 4x and a 2x, so that becomes plus 6x. And then I have minus 6 and minus 2, which becomes a negative 8. And that's it. However, if we have something like b, which is f minus g of x, that means we're going to write our f of x function and we're going to subtract our g of x function from that. So now what we have, I'm going to scooch this over a little bit. Now what we have is our f of x that I'm going to write in parentheses, 2x squared plus 4x minus 6. So that whole function I'm going to subtract g of x from. So g of x is 2x minus 2. Now here's where showing the parentheses is very helpful. I am subtracting this whole function g of x. So that negative sign needs to be distributed to both of the terms that are inside of the g of x function. So this becomes 2x squared plus 4x minus 6 minus 2x plus 2. And now I'm able to combine my like terms. So I have a 2x squared, and that's the only one, so it just stays. I have a 4x minus 2x, which is plus 2x. And I have negative 6 plus 2, which is minus 4. Now I'd like you to pause the video and try the try problems. Hit play when you're ready to check your work. For the try problem, we have f of x and g of x. Part A asks for us to add f of x and g of x together. So that gives me 5x minus 6 plus my g of x, x squared, minus 5x plus 6. Now because it was addition, we could go ahead and just combine like terms. So I would have a positive x squared, but then the 5x's canceled and the 6's canceled, so we would just get that x squared there. However, if we take a look at part B, we have subtraction. So it's very important we keep the f function first. So it's f of x minus g of x. The f of x function minus the g of x function looks like this. Now we are subtracting each term that's in our g of x function. So this becomes 5x minus 6 minus x squared plus 5x minus 6. Once we change the signs, we can go ahead and combine like terms. So that gave me a negative x squared. 5x plus 5x gave me 10x, and negative 6 minus 6 gave me a negative 12. Example 2 is when we're multiplying and dividing fractions. When we multiply two expressions together, like x plus 2, x minus 1, normally what we do is we would just FOIL this out. So we're going to do the same thing. When we have two functions multiplied together, we're going to FOIL. So I'm going to put FOIL by where it says multiplying. And when we divide, it's very similar to what we did in chapter 5. what we're going to have to do is factor our functions and then try to cancel stuff out. We also want to say when it is undefined. Remember, a function is undefined when the original factored, switch it over, denominator equals 0. Let's start with example 2, part A, where we're multiplying g of x by f of x. So the order that it's written in matters. I must write the g first. So I'm doing g of x, and I'm multiplying that by f of x. So my g of x function is right here. That's going to be 2x minus 2. And I'm going to multiply that by my f of x function, which is 2x squared plus 4x minus 6. Okay, so now at this point we're going to FOIL it out. Although normally we use the term FOIL when we just have a binomial times a binomial. It's the same idea if I have more than 2 terms here. We're going to distribute each term in the first binomial to each term in the second. So it's going to be 2x times 2x squared, which is 4x cubed, 2x times 4x, so that's plus 2 times 4 is 8x times x is x squared. Then I have 2x times a negative 6, so that would give me a negative 12x. Now I need to bring that sign with me, a negative 2 times 2x squared, so that gives me a negative 4x squared. Negative 2 times a positive 4x gives me a negative 8x. And negative 2 times negative 6 is a positive 12. Now at this point, you would like to combine your like terms. So I see I can combine my x squares and my x's. So that gives me 4x cubed. 8 minus 4 is a positive 4x squared. And I had a negative 12x minus 8x, so that's negative 20x. And then that plus 12 at the end. Part B is a division problem. So it's f of x over g of x. We need to make sure that we're following what it's telling us. So f of x needs to be in the numerator, g of x needs to be in the denominator. So f of x was, scooch it over, 2x squared plus 4x minus 6, okay, over 2x minus 2. You need to keep in mind that whenever I tell you to factor something, you should always, always, always check for the greatest common factor first. So I'm going to put GCF first. Taking a look at the numerator and denominator, both of them do have a a greatest common factor. So I can pull out a 2 from the numerator, leaving me with x squared plus 2x minus 3. And I can also pull out a 2 from the denominator, leaving me with x minus 1. Now I'm not done factoring yet. I need to check and see if I can factor this any further. This is a case 1 trinomial. So I can use guess and check. The factors of 3 are 1 and 3. Using different signs, is it possible for me to get a positive 2? Well, yes, if the 3 is positive and the 1 is negative. So that means this is 2 times x minus 1 times x plus 3. And now that it's factored out completely, I can see what cancels out. So I have a 2 and a 2, x1, x minus 1. So I'm just left with x plus 3 in the numerator. Now I need to determine when it is undefined, because whenever we have a quotient like this, we have x values that x cannot equal. And in order to see what x cannot equal, we need to look at the original factored denominator. So I can't look at my final answer because that doesn't even have a denominator. I need to look at my original factored denominator. So I started off here, but I pulled out a 2. So I would just set each component equal to 2, or excuse me, equal to 0. 2 will never equal 0, so that doesn't give me a solution. X minus 1 equals to 0 will give me a solution. I would add 1 to each side, which means x cannot equal a positive 1. I'd like you to pause the video and do the try problem. When you are done, just hit play and check your work. For part A, we had g times f of x, so my g of x went first, that's x squared minus 4, times my f of x, which is x plus 2, and we would go ahead and FOIL that out, so x squared times x was x cubed, x squared times 2 was 2x squared, negative 4 times x was a negative 4x, and negative 4 times a positive 2 is a negative 8. You would then combine like terms, however, there were no like terms, so that's your final answer. Part B, we had f of x over g of x, so the f had to be in the numerator, so I put that x plus 2 there, and then g of x had to be in the denominator, so that's that x squared minus 4. We then would like to factor. The numerator did not factor, however, the denominator was a difference of 2 squares. Okay, maybe write that if you didn't recognize it. It's a difference of 2 squares. It's one of our special cases from factoring. So A would have been x and B would have been 2. So it's A plus B and A minus B. The x minus 2's canceled, and I was left with the x plus 2's canceled. I'm left with x minus 2 in the denominator. So you did need to have a 1 in the numerator to serve as a placeholder. Also, we need to state when it's undefined. So we need to look back at our original factored denominator and set both of these equal to 0. X plus 2 equals 0 would give me negative 2 as a solution. X minus 2 equals 0 would give me positive 2 as a solution. So these are the two values where the function would be undefined.